All right, we are going to continue with chapter 6 and geometric sequences. So, key thing in a geometric sequence is that we have, similar to what we saw in exponential functions, a common ratio, meaning there's a relationship that involves multiplication between our terms. So if we take a look at this graph here, you can see we're going from 1 to 5 to 25 to 125. So we're multiplying by 5 each time. That value that we're multiplying by is what's referred to as the common ratio. So we're looking, when we're talking about a geometric sequence, for that multiplication relationship between our terms. In example 1 here, decide whether the sequence is arithmetic, geometric, or neither. So geometric, we're looking at that multiplication relationship. Arithmetic, we're looking at that relationship that involves addition or subtraction. Okay, that's when we're thinking kind of along the lines of something that's linear. And then neither, if it doesn't follow either of those two patterns. So if we look at example A, we're going from 120 to 60 to 30 to 15. So if you want to think arithmetic in terms of addition or subtraction, we would be going down by 60, then down by 30, then down by 15. So obviously there's no common relationship there, so it's not arithmetic. Then I would look, okay, what about geometric? You might be saying to yourself, I'm dividing by 2 each time, which is correct, but think about what you're multiplying by. You're multiplying by 1/2. So 120 times 1/2 is 60. 60 times 1/2 is 30, and 30 times 1/2 is 15. So this is a geometric sequence because there's a common ratio. And the ratio is 1/2. You can get your common ratio by taking your second term divided by your first term. If we look at example B here, we're adding, if we think arithmetic, we're adding 4, then adding 5, then adding 6. So we're not adding by a constant amount each time, so it's not arithmetic. It's also not geometric because 6 divided by 2 is 3. And if I multiply 6 times 3, I should get 18 as my second term or my third term, which I don't. So it's not geometric because there's no common ratio. So this one is neither. There is a pattern here. Obviously, we can see we added 4, we added 5, we added 6. We can know that the next term I'd be adding 7. So my next term would be 24, and then I would add 8 after that. But it doesn't follow either that arithmetic or geometric pattern. We'll save the try these for class. Write the next 3 terms in a geometric sequence. So you want to think about what the relationship is here. So 3, 6, 12, 24. Obviously, we're multiplying by 2 each time. So if you want to write the next 3 terms here, 24 times 2 would get me 48. So at 48, if I multiply that times 2, I'm going to get 96. If I multiply that times 2, I'm going to get 192. Your common ratio here was just 2. If we look at the next example, we are going 64, negative 16, 4, negative 1. Notice that our sign is changing each time. So you might be saying I'm dividing by a negative. In terms of multiplication, you're multiplying by negative 4. So your common ratio, negative 1/4, is negative 1/4. So again, we're going to multiply each of our values by that. So negative 1 times negative 1/4. My next term is going to be positive 1/4 or 0.25. Keep going here. We're going to get negative 1/16. And then positive 1/64. So you're just following the pattern, using the common ratio to find the next three terms. If we look at graphing a geometric sequence, okay, we're looking at almost like you're graphing points. So n is your position, aka where in the sequence it lands. So 1, 2, 3, 4, and 5. So this is my first term, my second term, my third term, my fourth term, and my fifth term. So we have 132. We have 2, 16, 3, 8, 4, 4, and 5, 2. So I'm treating these as my x values and these as my y values. I'm going to go up by 4s. So 1, 32 would be there. 2, 16 would be here. 3, 8, 4, 4, 5, 2. Don't connect the dots here, okay? But you can see the shape of the graph that's being created here with the geometric sequence. Notice that it's an exponential shape, as opposed to when we had an arithmetic sequence a couple chapters ago and it created a linear shape. Why? Because this is a relationship that involves multiplication. Last thing that we want to talk about here is creating the equation for a geometric sequence. So a sub n, let a sub n be the nth term of a geometric sequence with the first term a sub 1. R is your common ratio right in there. So a sub 1 right in here, that represents our first term. And then R represents your common ratio. So make sure you have that down. So let's take a look at the sequence. There's two parts to it. It says write an equation for the nth term. So that's our general form of the equation, and then find a sub 10. So when we're writing this equation, remember a sub n is equal to a sub 1 times r to the n minus 1. So we want to figure out what our first term is and our common ratio. Here, obviously, we can see our first term is 2. So a sub 1 is equal to 2. And our common ratio, r, we're multiplying by 6 each time. So times 6, times 6, times 6. Let's create the equation. So the equation is going to be a sub n is equal to 2, and I'm going to write it in parentheses, times 6 to the n minus 1. So that's my general form of the equation. When I need to find the 10th term, I'm just going to plug in 10 for n. So 2, and in parentheses, 6 to the 10 minus 1, which is 2 times 6 to the 9th power. Remember your order of operations. Make sure that you're doing 6 to the 9th power first, and then you're multiplying by 2. This is not 12 to the 9th power. Plug this in your calculator, and the 10th term here is 20,155,392. So again, two parts here, finding the general form of the equation for the geometric sequence, and then finding the 10th term by plugging 10 in for n. We'll go through the try these in class, as well as the word problem that follows. See you then.